Did it.
Live on YouTube.
All right.
Loading now. It just needed to be turned off. Turned back on.
So that was the trick.
Like literally. I think
Nice.
someone's.
Great,
Yeah.
Oh yeah, it's live. It's live now.
Oh.
Yeah.
All right. You gotta mute YouTube though, otherwise you get double audio. All right. No one say anything you regret saying. Please.
It's just deathly silence now.
Yeah,
Yeah,
hang
that's
on
great.
a minute. I'm just getting set up.
Cool. Well, we didn't invite anyone, so. Oh wait, do they get pinged if this thing goes live?
Yeah.
Oh, okay. So potentially expect 400 people to join.
Okay, now.
I didn't get a notification though.
You didn't?
Are you subscribed?
Yep.
Did you
Of
click
course.
the bell?
Oh yeah. I probably did.
Like and subscribe. Click the bell.
Like and
Yeah, dude,
subscribe.
you didn't do it right. Me neither. I didn't click the bell. I just liked and closed browser.
All right. Good to go, right?
Yeah. All right, and we've actually got our first user, Jacob. Hey, hello. Didn't get a bell, but just saw it in my feed. Interesting, awesome.
Welcome.
Well, welcome, Jacob. As you can tell, this is our first attempt at this.
No, no one will be able to tell that. Like.
Oh, yeah, not at all.
I don't
Not
think
the
that
deathly
shows.
silence or like the lack of agenda. No one can tell. Hey, geek till it hurts. I get it. I get the joke. What's up?
That is Sahaj Sarup from Lenaro. That is a buddy of mine that I was having a chat with earlier this morning. He hangs out in some of the same communities as I do. So thanks for joining, Sahaj. We are just getting started.
You want to give it another minute or so? You can kick it off and I can man the chat 1s and 2s for you.
I'm on the chat as well.
Sweet.
I guess I could join the chat
whenever
as
you're
me.
ready, David.
Yeah, we'll give it a minute, just in case folks are just seeing that we've gone live. No worries.
Is
the
Zoom
meantime-
automatically rotating? Not based necessarily on who's speaking?
Might be by voice. Yeah, it is by voice.
It does rotate.
Hopefully when you share, the share just dominates the screen. Otherwise that'd be weird. We need to get that elevator music that Petros had.
Oh yeah.
Yeah, for this awkward silence. Or John can play his guitar. It's just right there. Just reach out behind you.
We need Phil. He was keen to show everyone his £20 guitar. He's not here.
I did take it off the wall the other day.
Oh.
All right. Well, I think we can probably get going then. If more folks join in, awesome. Andrew, you're going to keep an eye on the YouTube chat, you said?
Yeah, Chris and I are here. We're
Awesome.
ready.
All right. Well, thanks everyone for joining for our very first live stream, calling it IoT Happy Hour. We're going to go over news, probably discuss some balena related projects that we've all worked on over the past couple of weeks, and then what we have in the pipeline. Any other, comments from audience members as we see the comments come in. We'll certainly try to address those as well. Just to kind of lay out the agenda real quick for today, though, I think, you know, it'll probably be a pretty quick one as we're just sort of getting figured out and sorted out here. I thought to start off, though, you want to, everybody, if you're ready, we'll go ahead and go around the virtual room and do some quick introductions. So I'll start us off. My name is David Tischler. I am a developer advocate here at Balena. So I am primarily responsible for the community. Up until recently, I had envisioned this role kind of doing meetups and public speaking at, you know, industry events and conferences and gatherings. But with the current state of affairs, we're going virtual for the time being. And that's fine. You know, that's actually pretty fun as well. You know, other developer advocates and other teams and other organizations are obviously in the same boat as we are. So, you know, make the best of it. With that said, next in my list here on Zoom, Chris, you're up. You want to say hello?
Hello, everyone. My name is Chris Crocker-White. I am a hardware hacker in residence at Balena, which means I try to focus as much time as I can on building cool projects that show off the platform, what you can do, and hopefully build some cool stuff at the same time. So I've been working on stuff like Balena Sound, Balena Dash, Balena Sense, amongst others, with my fellow hardware hackers here.
Awesome. Thanks, Chris. Tomas, you want to go?
Yep, sure. So I'm Tomás Migone. I'm from Argentina. I'm also a hardware hacker in residence, just as Chris. I joined like 6 months ago. Been working with the Balena Sound, Dash 2. Just recently, I've been working with a couple of projects related to machine learning on the Jetson Nano. I think that's more to come on that later. But yeah, building cool projects, as Chris said, trying to showcase the platform, and that's it, I guess.
Awesome. All right. Andrew, you want to go?
Yeah, hey everyone, my name is Andrew Nem. I'm here in the Portland, Oregon area. I'm the lead content strategist at Balena, helping folks build stuff for our website, our blog. So helping the happy hackers, you are happy hackers, hardware hackers take their projects to the rest of the world, whether that's like written content, videos, live streams like this, whatever it takes.
Cool. Alan.
Hi, everyone. I'm Alan Boris. I'm also a hardware hacker in residence here at Balena in Pennsylvania in the United States. And I too, as Tomas and Chris had explained, and working on cool projects to show off the Balena platform, and hopefully be going over 1 or 2 of those with you today.
Cool. All right. And John, I think you're last one up.
Hi, everybody. I'm John Tonello. I live in upstate New York, just outside the Syracuse area. And I'm a technical marketing lead here at Balena, which means I work closely with everybody else in this room, not just developing my own projects, but highlighting theirs, and particularly looking at how to extend what might be a one-off project into an enterprise project, so that you can take the value of Balena and extend it into everything you're doing with your IoT fleets.
Very cool.
Apparently,
all right.
Apparently that's hilarious, Andrew.
Yeah, I don't know why Andrew.
No, I just saw. Yeah, no.
We're messing around in the chat.
Yeah,
I see.
Having fun with the chat already.
He's bringing out the
Yeah,
steamed hands.
they're already
already.
trolling. They're trolling chat. I see it.
Did you bring enough for everyone? Did you bring enough for everyone?
All right. So as I mentioned earlier, as a developer advocate, I am, typically tasked with submitting talks to events. And next week was supposed to have been NVIDIA's GPU technology conference in Silicon Valley. And so we were all set to go and showcase some projects there next week, but unfortunately that has not panned out, of course, due to the global coronavirus issue. So I thought it would be cool if we took a few minutes to show off what we were going to demo in the booth next week. Tomas, do you have your Jetson Nano handy, and would you be able to cover kind of what you had put together for that event?
Sure.
Awesome, thanks.
Yeah, perhaps we can start like one step before that, which is with the AlwaysAI platform and what we were trying to do with that. I'm not sure. I'm trying to share my screen. Perhaps that's a good idea. Hold a sec.
Yeah, no worries. While you're doing that, I can actually cover even, a little bit of further back than that. Yeah, so the NVIDIA GTC event, GPU Technology Conference, is an industry event, typically about 3,000 to 4,000 people. So it's a big show. And it highlights and showcases all of the various uses of the NVIDIA GPUs. So that includes deep learning, that includes medical research, of course, that includes gaming, but there is also self-driving cars, there's robotics, there's augmented and virtual reality. So there's a lot of different industry segments that are covered there. We were set to have a booth in the Jetson Pavilion, which highlights work being done on Jetson Nano or some of the other smaller ones. There's the, I want to say TX2. I think there's a new one, perhaps NGX, if I remember correctly. But anyways, so point being, we were set to show off some computer vision applications running on top of the Balena platform.
Okay, so Zoom is not allowing me to, I need to restart Zoom to be able to share screen, so I'll just wing it.
That's all right.
Perhaps someone else, can share some of the blog posts as I go through it on the chat, in case someone is interested. But yeah, as David said, we were going to be part of the NVIDIA conference. We had a booth booked in there. So basically, we looked into what types of projects or what could we build and showcase that would be cool and maybe grab people's attention in there. I think at that point, maybe a couple of months ago, AlwaysAI, which is an AI/machine learning startup, they partnered with us. So we decided to try to build a project together, which that later evolved into a series of blog posts. But yeah, so basically the idea was AlwaysAI had already built a project, which is a people counter project. So basically, like they have this software running on Jetson Nano with a webcam, and it would just like grab frames from the web camera, process it, and detect and count the number of people in there. So the idea was was going to put that on the booth and like count the people that visited our booth. We saw that, we thought it was cool, so we wanted to integrate that with one of our own projects, in this case, Balena Sense, which originally Balena Sense is a It's a project that has a Grafana dashboard that talks with the various sensors. You have like air quality, humidity, temperature. So that type of variables get sensed and sent into the Grafana dashboard. So we wanted to like combine those two projects and into this Sense People project. So use a AlwaysAI platform, which I'll talk about more in a minute, to detect people that were visiting our booth, send that data into our backend services that we just took from Balena Sense, and show it on a nice UI, Grafana dashboard. So that's basically like the project we built for the conference. As David said, well, the conference didn't happen, but we have a couple of teammates. I think Sean, who lives in Barcelona, already has the project like running and with the webcam pointing out of its window into the street. So what he wants to find out is like if these extreme quarantine measures being taken because of the coronavirus, like if the amount of people on the street goes down with time. So I think he's been running that for 2 days, maybe 3. Still, numbers aren't, he didn't share numbers yet, so we'll see. But it's cool. I mean, it's a cool use case. Yeah, I don't know if anyone has any questions. Maybe I can go over a bit like what AlwaysAI does on different layers.
I just have a quick comment. So I dropped the how-to link in the chat for folks who want to check it
cool.
out. And, you know, as like a super low-level user, like I found it pretty amazing to get all that started within just, you know, you literally pull the code, install AlwaysAI stuff, push, you know, and then even take it so far as what did we do? We changed the object detector to detect birds / my chickens in the backyard. And that was as easy as just going to local mode, local push, changing that up and then pushing that live, and all of a sudden I was detecting barnyard animals. Like it's pretty crazy how easy it is to get started, and then after that it's kind of up to you as a user, like whatever citizen science or like professional work you want to do. It's kind of nice to like skip a pretty significant amount of software layers that are outlined in Tomas's blog post, just to get to a really cool use case. Let's check it out.
Yeah, that's a very interesting point. I guess one of the I guess machine learning and AI is one of the most scary I don't know, parts of software development. I know, I mean, it's not easy to get into it, and even like some senior software developers I know that don't like it because it's complex, or I mean, it has a steep learning curve. So the cool thing with both AlwaysAI and Balena platforms is that like combining those two, we managed to have these solutions where it's really easy to get started. You actually don't need to know anything about machine learning and how like neural networks work and operate, because everything is abstracted into like higher layers of software. So that's pretty sweet, and like even someone that only knows to code, for example, Python, can get started and do pretty cool things with it. So that's a huge.
I think that project it does a really good job of lowering the barrier to entry. It's like, as you just said, you can like get starting with coding without having to worry about all those underlying layers. So it's sort of, I think for me, it makes it a lot less daunting, and it's definitely something that I'd be more comfortable trying and having a play with.
Yeah, I mean,
now that project's there.
I took a look at one point at, you know, look for some getting started guides or some how-tos to get started with machine learning, or, you know, training and object detection and things like that. And you have to be a subject matter expert in that field. But the AlwaysAI platform was easy enough where I was able to just simply drop a container onto the Jetson Nano and I modified perhaps 2 or 3 lines of code, which is about the height of my skill set, but I was able to detect dogs. So I put it in the front room and I counted the number of times the dogs went and barked at the Amazon guy. So pretty neat.
Okay, Andrew. Yeah, that's nice. Okay, so
That's nice.
yeah, this is helpful. Somehow Zoom wasn't letting me stream my screen. So yeah, I am, as we said, like it's not easy to get started. Wait, Andrew, I think you need.
Oh,
you switched.
Yeah, Andrew, you're streaming.
bad.
Yeah, you're streaming. Thanks. So we have 2 blog posts, or actually 3 if we count Alan's, that cover a lot of machine learning and AI topics. I want to focus on this particular diagram because I think it's helpful to understand everything that's involved. So when you get, for example, a Jetson Nano board or any board from NVIDIA that are specifically designed and they are used for machine learning and AI processing. Like you get the board, you put an OS, you run an OS, and I mean it's a board, right? You can get into the SSH into it, but you don't have any of the required software drivers and prerequisites installed on it. And with the NVIDIA boards, that can be really challenging because there are a lot of things that are not necessarily easy to install and configure. So this diagram tries to illustrate that. So from bottom to top, like each layer is like a higher abstraction. So if we start from the first one in the bottom, first thing you need to install with one of these boards is the actual GPU drivers. Like you need to tell the Linux or the OS kernel how to interact with the hardware that the board has, and that's what GPU drivers are for. In case of NVIDIA, they have that packaged into L4T, which is Linux for Tegra driver packages. NVIDIA has a couple of tools and like special software that helps you download the drivers and other software packages that you need. It can be done manually. Alan has written a blog post on that, but it is a quite involved process, I would say. And you have a couple of different alternatives to try, so it's not always clear which is the best alternative for you. But yeah, the first layer is GPU drivers. Again, this is to tell the Linux how to deal with the hardware. From there onwards, like each layer, as I said, like is a higher abstraction. So the first thing we hit after that is CUDA. CUDA is a software library developed by NVIDIA, which provides a lot of like common functionality that you would need if you were doing parallel processing. So the GPU is very useful if you want to do parallel processing, parallel computations. In order to take advantage of that, you of course need to use software packages that can do that. CUDA is one of those things. So CUDA provides a lot of typical functionality that you would need when doing this that's already developed, which is it's nice. If you have the GPU drivers and CUDA installed on your board, you could theoretically start like working and writing machine learning algorithms. it will, I mean, you, in that case, you will need to be very knowledgeable about the subject, because it's not easy. CUDA, I think, only has like C or C++, maybe Python libraries or APIs, but it's really low level stuff. So that's why we have other layers. On top of that, if we go one step further, we have CUDNN. I don't know how this is pronounced in English. Couldn't. This library is also developed by NVIDIA, and what it does is another abstraction layer that implements typical neural network functionality. That in turn will use CUDA. So if you want to do things with neural networks and you use CUDNN, you can be assured that you will be using CUDA, and in turn will be taking advantage of the parallel processing of the GPU. So you can see how each layer it's built on top of the previous one. Each layer has like its own API. You can interact with it if you want to, but as you keep going up, it's easier to work with it. OpenCV is another example of this. OpenCV is a computer vision library. It's not developed by NVIDIA, but it's an industry standard library. OpenCV can be configured to use CUDA. So OpenCV also has libraries and methods to work with, for example, image processing. And you can do that without a GPU, or you can take advantage of your GPU through CUDA, and that will be a lot faster in processing times. So yeah, these three first layers are mostly NVIDIA proprietary software. And one of the things with this is that it's not super easy to set them up and install them. I don't know if you have shared it in the chat, but Alan has written a blog post that covers just installing these three pieces manually. You should check that out. And here's where AlwaysAI comes in. So AlwaysAI, as I said, it's a machine learning startup. What they do is they try to make all of this simpler for developers. So one of the things they have is Docker images, right? So the idea with AlwaysAI is that you use a Docker image that kind of packages these layers, and so that you don't have to do the work. If just by running that image, you will get, for instance, the drivers, the CUDA and CUDNN installed by default. So that's very handy. The name of the images they created is Edge IQ. Can you scroll up a bit, Andrew? A bit more to the, go back to the diagram, please. Yeah. So yeah, as you can see, like the first three are kind of packaged into this Edge IQ Docker image. So if you want to develop, for example, using OpenCV or CUDNN, and you use this Docker image, that's the only thing, the only setup you need to do. Like if your Docker file, the first line is from AlwaysAI /edgeiq/nano or something like that. Just by doing that, you get all of this software installed by default and configured, and you should be ready to go to write any software with OpenCV or CUDNN. So that's really good. If you combine that with Balena, again, you write a Docker file, you import the Docker image with the from statement, and you deploy it with Balena to Jetson Nano, the Jetson Nano already has everything configured, and it can take you a couple of minutes to do that. It's really easy. But we still have a couple of more layers and abstractions, which will go briefly. So what AlwaysAI did is, on top of this, they created this Python library, which they also named EdgeIQ. That Python library is also installed by default on their Docker images. And the idea of this library is to help you work with neural networks. Neural networks are also challenging in both in terms of installing them, of knowing what you need to install. You have like different frameworks. You can use TensorFlow, Darknet. Here are a couple of examples, PyTorch, and there are many alternatives. Each one has a different installation mechanism, different steps. So if you want to try multiple frameworks, you're probably gonna spend a lot of time sitting at a screen waiting for software to install. So if you use EdgeIQ Docker image, this is all solved for you. The image also has like all the files, all the dependencies that you need to work with these frameworks. So you don't need to do that. So that's, again, a huge bonus. On top of that, if we move one layer up, we get to the neural network models, which is once you select a framework, say you want to work with TensorFlow. Okay, you have different types of models depending on what you want to do. You have models that will do object classification, models that will do object detection, human pose estimation. There are sorts of stuff. You can even build your own model to detect or, yeah, to do whatever you want. You train them, and that's, yeah, you can have all sorts of models. Each model is also tied to a specific data set. I just noticed it says data sheet in there. That's a typo. We need to fix that. But yeah, the data set is what the model is trained against. So when you train a model, you train it to, for example, recognize chickens on an image. The data set is like the set of images you provide as a training input in order for the algorithm to get good at detecting chickens. If your data set is bad, your model will be bad. So there are also a couple of standard data sets, which also, if you do everything manually, you need to download them, you need to install them, which is actually just placing a couple of files on some directories. But still, each one of these layers is manual stuff you need to do. It's a couple of steps you need to do. They can go wrong, and they will probably go wrong. So if you use AlwaysAI, you don't have to think a lot about this, which is a good thing. I think we can now scroll a bit. Scroll to the Python snippet. Can you, Andrew? Thanks. So yeah, this is the last thing I want to talk about. Like, as I said, if you use AlwaysAI platform, if you use the Docker image they provide, and if you use the Python library that they provide, all of these 6 or 7 layers that we just talked about, they are installed and pre-configured by default. You need to specify what framework you want to use, what model you want to use. There are a couple of files you need to download, but it's a really easy setup. Once you have that, like this is a snippet from the actual code on the people detection software, that project that we had. So you can see it's fairly easy. I don't want to go too much into detail, but you can see you need to specify, okay, we'll be running this with CUDA enabled GPU. So we want to take advantage of that. We will be using a webcam, so grab frames from there. And then when you grab a frame, I want to do detect objects on the frame. you set a confidence threshold that's specific to the algorithm. And then that just gives you the results, right? Then we filter the results by person, because this the algorithm we are using can detect multiple types of objects. It usually goes from 20 to hundreds of objects that can detect. We are only interested in persons here, in people, so we only filter by that. And that's it. Like, this will give you an array of objects where each object will give you look at a bounding box for a person that was detected on the frame. So that's, you can see this is really easy, really simple. If you know Python, you probably don't even need an explanation. But yeah, you can see, you just by writing Python code, you can get started with machine learning. Here are a couple of screenshots and examples of this. This is the type of output you get. One of the things that the Python library from AlwaysAI has is like a built-in streamer that runs on port 5000. You can go there with your browser and it will show you this preview screen with the image that's being grabbed and the actual bounding boxes for the detections that are being run. You can see here is detecting me. And then on the screenshot below, that's the Grafana dashboard that I pulled from the Balena Sense project. I embedded the stream from AlwaysAI in there, and I also created like a unique visits chart. The idea was to show this Grafana dashboard on a screen on the booth, the conference, to kind of see like the trends of visits we had to the booth.
Yeah, that's awesome for that explanation. Thank you, Tomas. That's, you know,
yep.
You covered a lot of
Perhaps I got
ground.
sidetracked and
No.
I got a bit excited and went a bit into too much data. But
No. There's two things there. So first and foremost, you described all of the technical underpinnings of how it all works. And yeah, we were going to show it off in a booth, and that's great that people could walk up and see it all running in action. But you know, without having that background information that you just provided, people wouldn't really understand what they were looking at. So thank you for giving that. The second thing is this, I just put over in the chat, is that you just went through all of the gory details of what it takes to build out a project like this. But I think perhaps in another week or two, we'll be in a position to show this off. We'll do a live build, and, you know, for folks that happen to have seen this episode, they're going to see how easy it is to actually deploy it. So that's actually really cool that you were able to provide that background on it.
And we can do an app where, like, each one of us on the stream adds our own Jetson Nano to the same app as well, so we can have streams coming from all different places.
Yeah.
Sure. I wanted to add some color to Tomas's explanation too. Like, it wasn't a joke. It's actually really easy to swap out the detection model. Like, we used the one for bird in here in this example, and I'm gonna play the video. It's probably gonna look awful, but it works.
Yeah, so actually that's funny because Tomas built the project as a people counter. You altered it to a chicken counter. I took your chicken counter and then modified it to a dog counter. And like I said earlier, I counted the dogs every time they went up to the front window. I put the camera over above the window, and every time they came into the frame, it added one to the count. So I actually modified the Chickenator, not Tomas's project. So yeah, it's super simple. So it's great, Tomas, that you gave all of that background, because now in the future, maybe a week or two down the road, we'll do a live build, and people will see how easy it actually is.
And maybe we can hit up more about like how the models are always learning too, because you know, we in a different iteration, Tomas, we were concerned that like the bird object detector wouldn't know what a chicken was because no one's done the cycles. I mean, why wouldn't they? To teach it, it what a chicken
What a
looks like. 'Cause, I
chicken.
mean, even there, it's like I think this is 86%. I'm 86% certain this is a bird, and it's like, you're kind of right.
Yeah, the confidence level of the model is displayed along with the bounding box, or I think that's an option that can be turned off, but I had it on mine.
I think we need a fish option. Like we have people and birds and dogs. Like, who's got a fish tank?
Yeah, who's got a fish tank? Well, the fish are contained. They can't go anywhere.
I know, but we can at least keep an eye on them to make sure they're always there.
Yeah.
Well, that's just the fish cam. That's different.
That's a great segue into a serious point of this, where we actually do have customers or people using this kind of software and edge technology to monitor like the health of wildlife. Like this isn't all just like how many dogs and chickens and people are going through your home. There's a really cool use case. I can't remember the company name, but they're using these cameras in real time to monitor for like sicknesses and salmon runs. That way they can catch them early, make sure they don't lose the whole spawn. Yeah, it's pretty cool. Real use cases for this stuff. As well as the fun stuff, of course.
I mean, it is quite annoying when the fish escape and go wandering around the house.
Yeah, I mean, if the fish
that's
are
some
no
real
longer
cat in the hat kind of stuff there, dude.
Yeah. I mean, you got a whole different set of problems if the fish are not in the fish tank.
Yeah.
So, all right. well, anything else we want to cover, at least from the GTC perspective? Like I said, thank you, Tomás, for covering the technical background, and we'll do a live build of this and show it off. And then, we can add multiple devices, literally globally distributed, to the application, so we can show it running on Jetson Nanos across the globe. And then anyone out in the community that happens to have one can follow along as well. Is there anything else any of you guys want to cover on that?
I think Alan was tackling the open side of it, right? For folks who don't want to go through the hardware barrier of having to procure a Jetson Nano. It's kind of expensive, to be honest.
And there's one thing I didn't say, which is AlwaysAI is still in beta. So there's that. And I'm not sure if they will move into some sort of paid scheme or what once they get out of beta. So, I mean, there are, the manual alternatives, there will always be there. And I mean, we will always keep pushing that too, as we did with the Alan's project.
Yeah, the one that I've been working on is called OpenDataCam, and it's an open source project. It is optimized to run on the Nano. You could run it on another device, and it will try to use the GPU if available, but that's not guaranteed. This is a kind of a preview because this actually hasn't been posted yet. So this is a bonus for those of you who are on our stream right now, because this OpenDataCam article is upcoming, but just briefly say it's the polar opposite of kind of a way of doing AI that Tomás had described, because this one is, like I said, open source. It's very alpha and it's very build it yourself, where AlwaysAI pretty much gives you all of the layers that you need in their image. With OpenDataCam, we're building from scratch, and it's a lengthy build, but I think it's worth it because you get a pretty interesting project when you're done. Now, I can demonstrate that now. Do we have time for that, or do we want to save that for another episode?
I mean, I'm fine if everyone else is fine. I don't know if anybody has any hard stops. I know that we got a little bit of a late start.
I say we
anyone
end the
else?
stream with something cool because I think that project's pretty cool.
Okay.
Yep, +1.
Thanks. We'll give it a try. Then let me see if I can share my screen.
Did you say your prayer to the demo gods?
Let's see.
Is that the baddie off of Stranger Things?
So, I don't know, can you folks see my, I guess, desktop?
Yep.
Yep.
Good old
Excellent.
standard Windows 10 background. I love it.
Well, if I can just get it to, okay, there we go. So as I was saying, build it from scratch. This is the Docker file that we're using. And you can see that we're putting a lot of stuff in here. This is a huge Docker file to get all of this, all the dependencies that you need to run OpenDataCam. I'm not going to go through it step by step, but one thing to mention is that you do need to grab files that are downloaded from the NVIDIA SDK. So that's one difference. You download the files, you put them in a folder, and then you push this entire Docker file to our builders. And what you get after a lengthy build is OpenDataCam running on your Jetson Nano using Balena OS, and you get some nice benefits from that, including the public URL and just the ability to see diagnostics on your device and to be able to SSH into it from anywhere. I split out the database that OpenDataCam uses into a separate container. So you also have access to that, even if you enable the public device URL, you can access both the OpenDataCam API and the database that stores all the data. So let's just go right into it. If you copy the IP address of your Nano and then you click here, what you're looking at now is a live view of a camera out of a window. And this normally busy street is a bit empty these days. But there we see a car going by. It detected the car, and now we see a person making their way down the street.
Are you
and
sure? It's only 30% sure.
I know, it's only 30% sure. It's a confidence level.
Hold on, I think that might be a vehicle that just made a turn.
Old Mazda 3. Zoom, zoom.
Yeah. Now you'll notice a little bit of lagginess here. That's really just because of the way I have it built right now. But that's pretty intermittent, and it doesn't really affect the detections. It's really just the video, the streaming that's coming through. So like I said, it's unusual though that we would not have really a lot of cars going back and forth here, but this area is on a bit of a lockdown right now. So actually surprising the number of cars that are out there. I don't know where these people are going, but
totally ignoring.
Yeah, really not supposed to be any cars, but so this is just the live view. This is just showing you that it's working, but let's actually go into where OpenDataCam really gives you the interesting functionality. You can draw a line on the screen and it will count how many cars pass through that line. So let's just draw an imaginary line here. Cool. And you give that line a name. So I'll call it, I'm just going to call it N2. And you'll see as the cars pass through this line, when they're detected, they'll turn the color of the line. And you can specify all the line colors in the configuration file, which is pretty cool because you can draw multiple lines. So I'm gonna draw another line here for this street.
Ooh, name it, Chris. Just kidding.
I was just gonna say, what are the chances that there are no more cars now? Oh, there's one.
Oh, there you go.
Yeah,
I was gonna say.
missed that. But what's interesting is as they cross the line, they turn yellow.
Whoa.
Now that
Wait, what about that
truck was,
guy?
I know, he was a little too large. He didn't actually cross the line because a lot of that truck was there, but this one should cross both. So it turned yellow,
Oh,
and then it's going to turn hopefully blue. Yep, briefly turned blue. I don't know if you
Yeah.
can see that, but
I
hopefully
couldn't see it.
the next car. But what's interesting is now this again is just in a live mode. I'm going to hit start recording, and it's actually going to record all this data. It's going to record all the positional data for every frame plus counter data, and you'll see that update live on the screen. I just want to mention that OpenDataCam runs completely locally on the Nano. It's not streaming any video off the Nano as far as recording it, and it doesn't actually record video. It's just recording data. So recording might make one think that it's going to generate video files, but it just generates data files, which is really interesting, and it's great for any privacy concerns. So let's just start the recording, and now it's actually giving you a live count, which is cool. So there's
That's
one
cool.
car just went by.
That is incredible.
And what I'm also working on is a case study for this, because this street right here is a one-way street. And using the angle that you get the angle that the vehicle goes through the line. So using that angle, you can tell whether a car is going the wrong way. If the angle is greater than 180 here, because if you're going this way, that's about what, a 90-degree angle. But if it's greater than 180, you know that the car went this way.
So they're driving the wrong way on a one-way street then.
Sure.
Exactly. And I look out the window and see that, and I'm thinking, oh, this is a big problem. But is it really? You know, you see one, you just assume that it's massively happening. But hopefully soon I'll have some hard data to back that up. And I'm going to share that information in an upcoming piece about this as well. So let's just give this data another minute or two, and then I'll show you what the recorded data actually looks like.
Nice. Hey, Alan.
In the meantime, oh, sorry, Andrew, I apologize. In the meantime, I see that Anuj has joined our call, which is awesome. Thanks, Anuj, for joining. Anuj is in India, and he said previously in a conversation, I recall, that something like that would be very helpful because there's a lot of wrong way driving on the streets near him.
Yeah, I mean, like, I'm hoping that Alan starts a fleet, and then I'm able to add some devices here because we definitely have that issue. So basically the scene is like a couple of months ago, two major streets, both of them were bidirectional, but then they created like a circle. So it goes like a large roundabout. So it would be pretty interesting. So like not a lot of people are still used to that, and people just cut corners basically. But that would be a nice place to have some of these cameras.
I think we have, I see there's a couple more cars that just went by. This is actually a lag, so we'll stop it in a minute. But that's a good point that you have. This is easy to turn into a fleet, especially when you have it running on balena. It's easy to share the data. I think that's a great idea. So I was saying this is delayed probably by about 30 seconds just due to the processing that's required. So I'm actually looking at the live camera view from this camera and seeing that there's a couple more cars, and then we can stop this and just look at the data briefly so you can see how neat it is to use. Just a little info about the camera that I'm using. To zoom in like this, I'm using a HD consumer video camera, and then I have it going into a IP decoder. And I found that to be a bit more.
Oh no, the people.
People. It's not really supposed to happen, but that's okay. We have multiple cars going through. And it does detect people. I'll say right off the bat that
these people are supposed to be in their homes.
They are, but they are
Mhm.
6 feet apart. So that's,
Yeah,
that's
okay, they're
probably
social
allowed.
distancing, so there is
Yes.
that. Okay.
Yeah.
So Alan, can you draw a line and say, like, count the people and count the cars independently?
It won't do it independently, but you can filter the data. I'll show that in a moment, where you can filter it by, it'll tell you who passed through, or I'm sorry, what type of object passed through, a person, or all that data is recorded.
Can you filter direction at like its direction too, or is it just straight
Yep.
up like? Okay,
Yep,
cool.
absolutely. Here, I'll stop it now. So I've stopped the recording, and I'm going to go into the data screen, and you'll see that
That's cool.
each of my lines has a separate total here for people, cars.
Super
Download
cool.
this data, and then the tracker. I have to say, I'm not sure why it says -8 objects tracked. That's a little strange.
Yeah, wait a minute.
But I'm going to show you some data that I recorded a few days ago that was, I'd say, more legitimate. But normally you get this information as well. And if we look at the data, it's in either CSV for the counter or JSON for the tracker. I'm not going to just show you that. I've actually dumped it into a database. I just used a simple trusty access database. So let's look at what the counter data. This is the raw counter data, and it gives every frame of video an ID. It gives you a timestamp.
Wow.
The line name that we used, in our case, we had one named N2 and one named Chris. It looks at the object type, and every object that it tracks gets an ID, so you can track it through different frames, which is really cool. And then a recording ID. So every recording has a unique ID. Keep in mind, all this is also available either if you connect remotely to the MongoDB, or if you use the built-in OpenDataCam API. So you could really aggregate all this data together. So that's the counter. And let's just look at the tracker data, which is really very detailed. The main thing to notice here is that you get a bearing, which is the degree that it went, that the object was moving in the frame. So this is actually disconnected from the counter. To get the data you want, you really have to connect them together. So I built a query to do that, which I'll show you. But you get the coordinates of every item in the frame. So you notice the same frame is repeated here for each object that was detected in that frame, and it does it for every frame. So you'll notice for this set of recordings, I have 1,634 records in here because it's tracking everything. And then it does give a name to it and the confidence level. So let's just look at a quick query that I put together for this. First one, sure.
Do these cameras have where it is in relation to other cameras?
No, the cameras at this point are all independent. I mean, you could give them each a name, but they don't really know where they are. I'm sure you could do something with GPS.
I was just going to say, you would have to probably include some sort of GPS in order to, determine its specific location. And then you would probably need some logic written in order to determine, this location versus some other location. I don't know that OpenDataCam has that functionality native to it.
But
maybe
we should add that, yeah, the fleet does. You do have location services for every device in the Balena cloud. So if the camera is situated right next to the Nano, that information is available through the dashboard.
So what I was getting at is, like, since each vehicle has a unique tracking ID on the OpenDataCam, can it hand that information over to the next camera? Which is also part of the same fleet.
Yeah, I don't think it does it natively, but it's open source. I think
Right.
would be something that somebody could add to it. And
I was thinking how we could include like the fleet angle to it. That's what I was getting at.
Yeah, I think it would be possible, but tough. You'd have to work on that GPS GPS data in order to do that kind of handoff, since they are processing locally on each device and they're independent, you know, there would be some work involved in trying to figure out how to connect the object IDs from one to the other. I'm not saying it couldn't be done, but I think that would be challenging.
True.
But as far as this is a simple query that's just aggregating the recording IDs. If I run this, it just tells me how many each recording that I have and when it stopped and started, the time that it stopped and started. So I would just copy one of these recording IDs from this query, because this is basically my catalog of recording IDs on my device, and then go into this query, which is really the crux of what I was trying to do. And this just connects the counter data to the tracker data using a recording ID that you specify here. And I'm only looking for confidence levels greater than 80. And I'm also converting that timestamp to my local time as well. And when I run this, and it's pretty amazing how fast this runs, considering what it's connecting 1.6 million lines together. But this is basically everything that I tracked in one of the recordings. All cars and one truck where the confidence was greater than 80. And then it gives me the time that it happened and the bearing. So what I'm really interested in is any bearing greater than 180, which means that the object crossed that line that I drew at an angle indicating that it was going the wrong way. What it looks like to me is we have two of them really, but the main one is this truck that crossed at an angle of 251 degrees, which is obviously a violation. So
at 5 p.m., which is a high traffic time as well, 4:58
exactly,
p.m.
So not ideal, but this is only for about an hour. So you'd obviously want to do this at the same time, day after day, and really aggregate that data. But I just wanted to show how you're able to grab that. I might be a little suspect on this one because it's pretty close to 0 degrees. So I have to look at that to see how it's doing that. But if we go back to the
shout out to Microsoft Access, doing a great job, doing a wonderful job.
It's just the data is stored in a MongoDB database, and it's not really easy for someone like me who hasn't done a lot of NoSQL to connect the two. Like, they don't even call them tables, right? I forget, collections, whatever it's called in MongoDB.
Yeah.
I found it very difficult to connect those two together to get the counter and the tracker to, to connect. So maybe that's just me, but it took me only about 3 minutes in Microsoft Access to do it. So, you use what you know. I guess I've used that for years, but you could obviously use any database you want. You could put it into MySQL, whatever works. Or if you know MongoDB, you could probably connect the data together really quickly. But that's basically it. This can do a lot more. I think what's cool is to look at the Pathfinder real quick. That just shows you, draws a path for every vehicle that it detected.
Oh, that's neat.
Yeah. So you can get an idea of
wow,
everything's going.
Whoa, that is insane.
Yeah, so there's a lot more that it does, but I'll just leave it at that for now. That's kind of the main functionality of OpenDataCam, coming soon on our blog.
That's awesome. That's a cool project that you're working on. And anyone watching got a sneak preview because that's not written and published quite yet. So very cool. Thanks, Alan.
You're welcome.
All right. Well, I think this is probably a good point to wrap up then, unless anyone else has any final comments they want to make. Anything else?
I don't see any new questions that haven't already been answered.
No, let me take a quick look at chat. Looks like
I want to know what's coming up next week.
That's a good one.
Well, that is a good question. And I have an answer, but I'm a little bit concerned that I'm not going to have parts in time. So I ordered, let me make sure you guys can see this. I don't know if the camera will pick it up or not.
What is that, man?
This is a Pimoroni breakout garden. So the Balena Sense project uses a Pimoroni BME 680, which has temperature, humidity, air pressure, and air quality, but it requires soldering to put it together. I am not real good at soldering. So they make this adapter, they make this hat that you can just plug the 680 directly into. Then you place the whole thing on the Pi, and you have the exact same hardware, but without having to solder bits and pieces together. So I've got this breakout garden hat, but the sensor has not arrived, and it's coming from Europe. So I'm not entirely sure that I'm going to be able to do this live build. My goal was to do a live build of Balena Sense, and, you know, get it up and running and show it off, show it in action. But now I'm a little bit concerned if the 680 doesn't arrive in time. Might have to do something else, or may have to use a Sense hat.
No, we can't use the Sense hat. That's forbidden.
I have a
No,
suggestion.
I think we should use the Sense hat and just forego the air quality. But we'll see. Maybe the part will arrive.
I have two suggestions.
All right, go ahead, Andrew.
One is for those folks who aren't working for Balena or on the stream, you can sound off in the comments or on social somewhere with what you'd like to see. Yep. One other backup one, since this is a time of high stress, is perhaps we could stream a setup of that Minecraft project and play a little bit of games if people are interested.
That's a good one too. That is a good one.
That one is pretty low bar of entry hardware-wise. Software-wise, yeah, you probably have to pick up a copy of Minecraft, but I mean, who doesn't have that at this point?
A lot of people.
We can build a Balena OS device in Redstone Logic within the hour.
Yeah, I will pass on that.
Chris, giving you anxiety?
I don't want to see that again.
So those are both excellent suggestions as well. We could do the Minecraft. I wonder if Alex Programmer DE would be available. We could even reach out to him and see if he's around. Otherwise, yeah, we can definitely go through that build, through that guide, and fire up a Minecraft server.
Another option is, there are a lot of questions that were in chat, and perhaps an episode could just be a Ask Us Anything for folks who have been dabbling with the platform, tinkering around. If there are any questions, I mean, save support for the forums. That's probably where you'll get the best support. But you can ask our hardware hackers and teammates. Spreading questions.
Do an AMA. Could do that as well. So I think it would be good to we can sort of regroup as a team, figure out what we want to do. And I know that we didn't post this in advance. Oh, sorry, Amazon must be here. Apologies. But perhaps we could come to a consensus, and we'll post it, on social media, and even get a little bit larger audience next week as well.
Okay, sweet.
Sounds good.
Thank you, everyone. Definitely appreciate it.
Remember to like and subscribe and hit the bell and stuff, and we'll see you sometime
next week. Hit the bell.
Yeah.
All right. Bye, everybody.
Take it easy, everyone.
Bye.
Bye.